So today we're going to cover section 6.2, which covers radicals and rational exponents. So the thing we're going to start with today is a new vocabulary word called the root, or in this case, the nth root of a number. And nth is just trying to say any number. So it could be like the 7th root, or the 9th root, or the 3rd root. So just replace n with a number. And the big important understanding for today is that a root of a number answers this question. What times itself that many times is the original number? So for instance, if I was thinking about the question, what number times itself 3 times would be 8? Well, I'm thinking about what times itself 3 times would give me 8. Well, that's easy. It's 2 times 2 times 2. So this tells me, and I'd ask you to write this on your notes as well, the 3rd root of 8 is 2. So the symbol that we use to indicate that question, so what I'm trying to also point out is that these two things are the same. These symbols and that sentence are the same exact thing. So when I see this symbol, it's what times itself n times would give me a. So again, that's just the symbol, and we'll do some examples so we can interpret what that means. So I see that radical symbol, and again, that's called the radical sign. The radical sign is just that tabletop looking thing. The n, if we want to be fancy about it, that number is called the index. So we have a radical symbol, and we have an index of that radical. So here I see that this number is a 4, and I see a radical. So this is asking for the 4th root of the number 16. Now, as I did above, and I wrote it on your notes here, a really easy way to find whatever number root you're looking for is to just make that many boxes and fill them with the same number. So for instance, if I'm looking for the 4th root of 16, I would need to make 4 boxes. And I know that when I multiply them all together, I should get the number 16 at the end. So then if you're unsure, you can just start doing guessing and checking. Like I could start by filling them with 1s. 1 times 1 times 1 times 1 is not 16, so it's not 1. Then I would try 2, and I realize that 2 times 2 is 4, times 2 is 8, times 2 more is 16. So I found 4 numbers that multiply together to be 16. So the 4th root of 16 is what did you put in just one box? So that answer, the 4th root of 16 is 2. Or in other words, what times itself 4 times is 16? Well, 2 times itself 4 times is equal to 16. So we'll do another example here, which you'll need to add to your notes. Here we're looking for the cube root, and there's another little vocabulary word. Instead of third, we say cube. So what is the cube root of negative 27? So in other words, I'm asking myself, if I had 3 things multiplied in a row, because the index was 3, their product would be negative 27. And I need to put the same number in each box. So some hints here. I know they can't be positive numbers because a positive times a positive times a positive would equal a positive. So if I have to put the same sign in every box, I'm going to do a negative number because a negative times a negative times a negative would be a negative. So it's obviously not going to be 1, so I could try 2. 2 times 2 times 2, that's only 8, or negative 8 in this case. So I'd move on to 3. Negative 3 times negative 3 is positive 9, times negative 3 again is negative 27. So I found the number that I would put in each box, and the number that I put in each box is the answer. So the cubed root of 27 is negative 3. And the reason we know that, what I'm saying is if I took this number negative 3 and multiplied it by itself 3 times, I would get back to negative 27. Now this last one that you need to add to your notes is here for an important reason. If the number is missing, like here there's no number, so if there's no index listed, it's assumed to be the square root. Or in other words, if there's no number there, we assume it's a 2. So for this example, I'm wondering what would I multiply by itself twice to get 36? We can see here that number would be something like 6. So moving forward, rational exponents are the next thing we're going to cover. Now, rational numbers is just a number that can be expressed as a fraction. Now, as a fraction just means it could be written using like a numerator and a denominator. Some numbers like 4 don't look like they're fractions, but we could make them a fraction. So here we have a little example for you that you need to add to your notes. So if I see a radical sign, right, we see that radical symbol, and it has a root, what we notice is the way to write a radical symbol using a rational, or in other words, a fractional exponent, is we can see that the root in the radical becomes the denominator of the exponent. So it's nice to label here that the root is the denominator. Now, all we want to do here is evaluate the expression, but we're also going to write them as rational exponents as practice. So here, what I notice is the number under the radical sign is negative 125. And then I can see here that the index was 3. So if I'm going to rewrite this using a fractional exponent, the bottom would be a 3. And as we recall from our rule up here, right now we're just replacing that numerator with a 1. So the cubed root of negative 125 is the same thing as negative 125 to the third. So if I wanted to figure that out, I would make 3 boxes because that's my index, right? We can see the index here or there. And what would I put in each box to get a negative 125? Well, 3 numbers in a row, I know would have to be negative. And if I place a 5 here, negative 5 times negative 5 times negative 5 does give me negative 125. So the answer to this question, what did I put in each box, was negative 5. Let's try that again with something like this. So first, let's rewrite it with a rational exponent. So our base is 64. So the exponent, the denominator, becomes the root. So if our root was 6, the denominator here would be a 6. So when I see the exponent of 1/6, I'm just asking myself, what would I multiply 6 times in a row? So I make 6 boxes. And their product should be 64. So I'm going to try 1. That doesn't work, so I'll try 2. And we can see that 2 does work, right? This is 4. This is another 4, and this is another 4. 4 times 4 is 16. 16 times 4 is 64. So the number we put in each box was 2. So that is the 6th root of 64, or in other words, that is 64 to the 1/6 power. A few more examples that you'll need to add. Here we can see that it starts as a rational exponent. So what are we asked to do here? Well, if I see that, it might be helpful to turn it back into a radical. So when I see a fractional exponent, I make my radical symbol. Our base doesn't change. Now I can see that the denominator was 4, so that would be the index of my radical. So once I know that it's a 4, I'm just asking myself, what times itself 4 times would give me 16? And that number, of course, would be 2. If I filled these all with 2's, 2 times 2 times 2 times 2 is 16. So the answer here is 16. 2, because that's what we put in each box. The last one here, I just like this last one because we're remembering from previous knowledge, just to watch out with the negatives and exponents. So here, that little exponent is only applying to the 8. So if it's helpful to rewrite this as negative 1 times 8 to the 1/3. Remember, if it wanted to use the negative as well, we would need to include parentheses. So here we can just continue. That negative 1 we'll just leave as a negative 1. But when I see a fractional exponent, we can always convert that to a root. So the base is the base, and I see that the denominator was a 3, which means we are taking the 3rd root. So to figure this number out, I'm asking myself, what times itself 3 times would be 8? And we know that that number is 2. So in the original problem, what we were trying to do is we were trying to take the number negative 1 and multiply it by whatever the cubed root of 8 was. So the cubed root of 8 was what we put in each box, so that is a 2. So we're really trying to multiply negative 1 by 2, so our answer is negative 2. Now, rational exponents are used for roots of numbers. So whenever we see a fractional exponent, we will be taking like the 3rd root or the 6th root or some sort of root. But more generally, we can use fractional exponents to represent 2 things. And as I have in your notes here, because a fraction has 2 parts to it, we can have a nice, easy reminder that there's 2 things that a fractional or rational exponent means. So again, here what we mean by rational is just a fraction, if that helps you remind yourself better. Now, here we have kind of like our our definition, and you'll notice that part of it is missing on your notes. So I'd want you to write this part on your notes that I'm highlighting now. So like the A is our base. And then we have a power that's a fraction. We have m and we have n. So we know that b is always our, or that blue thing, a, is our base. Whatever that number is considered our base. Now what we know from just up here is that if we see the denominator of a fractional exponent, we know that's the root that we need to take. So when we see this, well, we know that the bottom number is the root to take. Now what's nice here, are a new piece of information, the numerator is the power to raise to. Now what I mean to raise to, I'm gonna maybe change that. It means to raise the base to. So if I were to rewrite this, our base is a, so we'll keep that as a. Now we're gonna rewrite this using a radical symbol because we saw a fractional exponent, right? So I'm just gonna indicate that, a fraction. Indicates we might need that radical symbol. So we'll put the radical symbol there. Now what we notice is the root, right, is in the bottom, so the n would go there, and the power m would go on the base. So that's how we'd rewrite it using radicals. And what's really nice here, and I'm gonna have you add over here in your notes, is you can perform in any order. What I mean by that is you can do the root first, and then the power. Or you could start with the power first and then do the root. So let's take a look to see what that looks like. So if I see something like 16 to the 3/4 power, the first thing we would want to do is rewrite that using a radical symbol. Because I see the fractional exponent, right, that fraction right there is indicating that we are going to be using a radical symbol. So let's draw our radical symbol, and I'm just highlighting in orange so we know where that came from. We saw a fractional exponent. Now we know our base is always our base, so we'll put that as 16. And now we know the denominator of the fraction is the root. So the root is the index. And then we have the power of 3. So after we rewrite it, then we can start to figure out what would we want to do first. So what we need to do is we need to cube something, and we need to take the 4th root. Now I don't know what order I want to do those in. So first I'm going to think about the cubed first. I don't know what 16 cubed is. That's too hard for me to do without a calculator. So since I don't know that, I'm going to do the root first. So what that means is first I'm going to think about 4 boxes. And I don't care about the power right now. I just want those 4 boxes to multiply to 16. So I know that that is the number 2. So the 4th root of 16 was equal to 2. So then I'll do the power last. So the power that I needed to do was 3. So I'll put that 3 on 2. So if I'm taking 2 and multiplying it by itself 3 times, I get 8. So again, it doesn't matter which order we do it. Let's look at another one to see what order here I might do. So when I look at this one, again, I see a fractional exponent. So we will make our radical sign. The base is always the base. The denominator is our root. And the power is the power that we can put here. Or if we wanted to, which I will explain in a moment, we could write it by first saying we're finding the cube root of 27. And then we are going to take that to the 4th power. Or we could write it like this. We could say 27 to the 4th power, all to the 1/3 power. There's a lot of different ways that we could be writing these. The way that we want to evaluate this is whatever is easiest for us. Is it easier to start with the cube root of 27 inside the parentheses and then raise it to the 4th power? Or do we know what 27 to the 4th power is? Well, 27 to the 4th power is too hard, so I'm first going to start with the cube root of 27. So what times itself 3 times is equal to 27, and I know that's 3 because 3 times 3 times 3. So once I have that number, 3, now I'll do the final exponent of 4. So 3 to the 4th power, we know, is 81. So we have one more example to cover today, which looks to be this. So the first thing we want to do is just to remind ourselves that we're working with rational exponents. So we know that the power on the base is the numerator of our rational exponent. And we know that the index of the radical is the denominator of our rational exponent. And we know that the base, or the number under here, is always the base. So if our base is 100, we can fill that in as our base, 100. We can see the numerator of the exponent would be 3. And recall from before, if there's nothing here, it's implied to be a 2. So we're trying to figure out here is 100 to the 3/2 power. Now here we're just going to summarize that the order, how we'd write our work, and depending what order we're going to do. So if I wanted to do the root first, the way that we would write it is I would take 100 and I would use the radical. So the root here, remember, is 2. So I'm going to do that first. Now if I'm going to do that first, I'm going to use grouping symbols, so parentheses. And then we'd put the power on the outside, right? So this uses our power to a power rule to show us equivalence. So what we would do here is we would first do inside the parentheses. So the square root of 100 is 10. And then I'd raise that to the 3rd power. So I'd write 10 times itself 3 times, which is 1,000. If you were going to do the power first, the way that we would write that is first we would do 100 to the 3rd power, and then we could use our rational exponent to say that we are going to do the 2nd root after that. So here, this would be 100 to the 3rd power. So that'd be 100 times 100 times 100. And then we would take that to the 1/2 power. So the square root of that, we still get the same number of 1,000. We don't want to write it like that. We could use it, or write it using the radical symbol. We could do it like this. I would just, oops, sorry, not 1/2. That would just be a 2, excuse me. Now remember, the radical symbol is a grouping symbol. So if I write it like this, before I take the square root of a number, I need to figure out what number am I taking the square root of. So just like on the left-hand side, we use parentheses to indicate what we're doing first, we could also use the radical symbol to indicate what we are doing first.